So continuing our discussion on radioactivity and radiation and looking at radioactive decay. I want to kind of work through a couple examples to show you what this looks like. Because we've talked about the three types of radiation. We have alpha particles with a mass of 4, 2 protons. We have beta particles with no mass, charge of -1. And then we also have, and we will see this, it's kind of a subset, is positrons, which are 0 with a +1. And then finally, gamma rays. Particles, particles, and rays. So one thing I wanted to talk a little bit now is about beta particles. As we mentioned, primarily we'll focus on this first one, which is essentially it's an electron. So -1 was what we write down there. And so the example that we can use is with carbon-14, radioactive, used for carbon dating. So carbon-14 . So what that carbon-14 tells us is that there's a mass of 14, because it's carbon, look on the periodic table, 6 protons. So that means we have 6 protons, 8 neutrons. And so what happens, what happens with carbon-14 when it undergoes radioactive decay is that it gives off a beta particle. So the way we write this is carbon-14, 6 positive charges are protons, total mass of 14. And what it decays to is it decays to nitrogen. Plus the beta particle, 0, -1. And then there's actually some energy. And so this symbol right here, we'll see this more often, but this is one of the symbols that we'll see for radiation, the energy of radiation, like a burst of energy. And so right away when we look at this, kind of the question pops up is, especially when we focus down here, what we have is that we're going from carbon, which has 6 protons, to nitrogen, which has 7 protons. So how on earth does that actually, what does that look like? Like how are we just making protons out of scratch? Well, the short answer is no. We're not just making protons up out of nothing. There's one thing of note is if we look at the mass, what we see is the mass doesn't change. Mass of carbon-14 is 14. Mass of nitrogen, 14, is 14 as well. So the mass isn't changing. So what do we have on this side? We start off, we have 6 protons and 8 neutrons, and we're going to 7 protons and 7 neutrons, because that's what nitrogen has. 7 protons, 7 neutrons. So in looking at that, we can kind of start to see how we can get from one to the other. And what we see that happens is that we take a neutron, which has 0 charge, And so if we remember, neutrons are, like I said, they're essentially the same size as a proton. And what happens is that we essentially split that neutron into a positive charge, a proton, and in order to maintain our electrical balance, we have to produce an electron. And so that is essentially what we have with a beta decay, the formation of a beta particle, is that in that atom, one of those neutrons splits into a proton and electron. Mass stays the same because the mass of the neutron is the same as the mass of a proton. The electron essentially has no mass. It has mass, but its mass is very, very, very insignificant compared to proton and neutron. And so this is kind of the underlying process for beta decay. Formation of beta particles. Because this electron is our beta, is the actual particle itself. And so that is how we're able to not see a change in a mass, but suddenly have it go from carbon to being nitrogen. Because when we convert this neutron to a proton, then it changes the nature of the atom, and it actually changes the atom itself. And so this is a kind of an intro into, or kind of the mechanism behind beta radiation.